lesson for today. I'd love for you to pause the video and try the warm-up first. All right, hopefully you have tried it. So this is what we learned last class. We've got sine of 11 pi over 6. So if you want to use your unit circle, you can. Or if you think about it, if you count all of your pi over 6s, 11 pi over 6 is 1 short of 12 pi over 6, which would give me 2 pi. So I know it is going to be in this quadrant. So this is my 11 pi over 6. I know at normal pi over 6, that would be, let's see, root 3 over 2, 1/2. So in this quadrant, it's also root 3 over 2, 1/2, except our y value is negative, so this value is going to be negative. We learned last class that in an ordered pair, cosine comes first, so cosine is the x value, sine is the y value, so that means sine is negative 1/2. So cosine 3 pi over 4, we've got 1 pi over 4, 2 pi over 4, 3 pi over 4, so it's going to be in this quadrant. I know pi over 4s are always root 2 over 2 or 2 over 2. So anytime you see a pi over 4 around the unit circle, that's what it's going to be. And in this quadrant, the x value is negative, so this value is going to be negative. So that means cosine is negative, so it's going to be negative root 2 over 2. For tangent, tangent is the tricky one. So 5 pi over 3, we've got 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So we are in this quadrant. I know that at normal pi over 3, it is 1/2 root 3 over 2. So down here it's the same thing, 1/2 root 3 over 2. Except in this quadrant, y is negative. So I know this is going to be negative. So we know tangent is sine over cosine, so it's going to be negative root 3 over 2 divided by 1/2. So we could multiply by the reciprocal of the bottom. So if I simplify this, I'm left with negative root 3 over 1. So tangent is going to be negative root 3. Finally, we've got cosecant of pi over 6. So pi over 6, I mentioned up here, is going to be root 3 over 2, 1/2. And cosecant is the reciprocal of sine, and sine is the y value. So it would be 1 over 1/2. So if you multiply by the reciprocal, you're going to be multiplying by 2. So cosecant at pi over 6 equals 2. So hopefully you guys are able to do that on your own. So new thing today is really just combining what we know into different ways of writing things. So this is identify the 6 trig functions for the given point, plot, and make a triangle. So if I plotted the point negative 3, 4, I'd go negative 3 in the x direction, 4 in the y direction. So if I make that triangle, my x value is negative 3, my y value is 4. So if I did Pythagorean theorem with that, 4 squared plus 3 squared equals c squared. So if you know special triangles, a 3, 4, 5 triangle is one of our special right triangles. So if you do this, you'll get 25 equals c squared, square root. So c equals 5. So this should be 5. So our theta here is right there. So you always make the triangle with the x-axis. I should have mentioned that. So when you plot the point, drop a line down to the x-axis. So drop your altitude to make the 90 degrees with the x-axis. So now they want us to find the 6 trig functions. So we're going to do our sine, cosine, tangent, and then the reciprocals, cosecant, secant, and cotangent. So sine is going to be, so we got to break out SOHCAHTOA. Brain is still a little bit not functioning because I'm sick. All right, sine, opposite over hypotenuse. If it helps you, remember you can label these opposite, hypotenuse, adjacent. So opposite over hypotenuse is 4 over 5. Cosine is adjacent over hypotenuse, negative 3 over 4. I don't know why I wrote 4. I think I read that h is a 4. That's confusing. Okay, over 5. Sorry, it should be an h. All right, tangent, opposite over adjacent, so 4 over negative 3. So notice the hypotenuse is always going to be a positive number, and it's the x and y values that could be negative. And then for the reciprocals, you just flip them over. All right, there are your 6 trig functions. So why don't you guys try the next set? So pause the video, try it, and then if you want to listen, you can. All right, if you've tried it, what you should do is graph the point. So we went 5 in the x direction, negative 12 in the y. If you do Pythagorean theorem, you're going to end up getting 13 for your hypotenuse. So this is our theta. So this is my opposite adjacent, hypotenuse. So if we do the 6 trig functions, sine is opposite over hypotenuse. So we've got negative 12 over 13. Cosine is adjacent over hypotenuse, so 5 over negative 12. And tangent is opposite over adjacent, so negative 12 over 5. Then we do our reciprocals. Cosecant is going to be negative 13 over 12. Secant is going to be negative 12 over 5. And cotangent is going to be 5 over negative 12. All right, hopefully that makes sense. Next type. This is find the values of the 6 trig functions that fit the constraints. Okay, so the constraints are a little bit different. Something I want you to notice. Here, it's telling you sine is a positive number. So this one's positive. And this is saying cotangent is less than 0, so it's saying cotangent is negative. So we need to figure out which quadrant is sine positive and cotangent or tangent negative. So I taught you guys that we did this ASTC thing, so all students take classes. So here all things are positive, here sine is positive, here tangent's positive, and here cosine's positive. So in the second quadrant, that is the only place where sine is positive, but tangent or cotangent is negative. So I know that I'm going to be working in this quadrant. So if I drew this out, in this quadrant, sine is opposite over hypotenuse, so this is my O over H. So my opposite is going to be 3, my hypotenuse is going to be 5. And then if you do Pythagorean theorem, you're going to get this side is 4. So then they want you to list the 6 trig functions. So you would do your sine theta, which they already told you is 3 over 5. Cosine theta, we've got opposite, hypotenuse, adjacent. So it would be 4 over 5. Tangent is opposite over adjacent, so 3 over 4. I probably don't need to be doing all of these for you, but I've already started, so I'm just going to finish it. Cosecant, secant theta is 5 over 4, and cotangent theta is 4 over 3. Okay, so the interesting part here is you just have to look at the constraints, look at what's positive, what's negative, and find the quadrant where that fits those restraints. So I'm going to just show how to set up this next one, but not find all the trig functions. So this one tells me that cosine is negative, and sine is less than 0, so sine is also negative. So you want to find a quadrant where both of those things are negative. So in my all students take classes, here all things are positive. Sine's positive here, cosine's positive here. So the only place where both cosine and sine are negative is this quadrant. So when you draw your triangle, it would be in this quadrant, and it would be, this is my adjacent over hypotenuse. So for my theta, adjacent would be 4, hypotenuse would be 5, but I went in the x direction negative, so it'd be negative 4. And then this is a 3, 4, 5 triangle again, so this would be 3, but it's negative because we went in the negative y direction. And then you would find your 6 trig functions from there, but I trust that you guys can do that now. All right, the very last thing is the key term of the day. So our new key term is a reference angle. So I've kind of shown this a few times today, but it is creating an acute angle made with the terminal side of the angle and the x-axis, and it will always be set as a positive angle. So to find the reference angle for these, 135, if I graph the angle 135 degrees, that would be around here-ish. So that angle is 135 degrees. So if I drop an altitude down from there and make a positive acute angle with, if I make an acute angle with the x-axis, what I'm wondering is what is this angle, and that is my reference angle. So the way I could find it is this: I just do 180 minus 135, and that tells me that that angle is going to be 45 degrees. So my reference angle is 45 degrees. For the next one, negative 3 pi over 4. Remember, going this way around the unit circle is positive, going this way around the unit circle is negative. So normal 3 pi over 4 would be in the second quadrant, so I'm actually going to go the other way, and I'm going to end down here, because I'm going in the negative direction. So that's negative 3 pi over 4. So if you dropped your line down and made this reference triangle here, or reference angle here, this is 3 pi over 4s, so we know we're going by 45 degrees, so this reference angle should be pi over 4. So your reference angle should be an angle that's in your first quadrant. So like 45 degrees, pi over 4, those are both angles from the first quadrant. So I'd love for you guys to try that for these 4. So if you could pause it, try these out. All right, hopefully you tried that. So 215. 215 would be over here, so it would be all the way around there. So if you made your reference angle, it would be this. So if I wanted to find out what that is, I would do 215 minus 180, because that would get rid of this part of the triangle and just leave me with that little reference angle. So that is 35 degrees. So my reference angle is 35. For negative 325, I would go all the way around, so it would end somewhere in here. So to make my reference angle, I've gone almost all the way around the circle, but I've left this piece out. So a whole circle is 360. So if I do 360 minus 325, I get 35 degrees. And here's 7 pi over 6. I know 7 pi over 6 is here. So if you make the reference triangle, it is a pi over 6. So I know this reference triangle is also going to be pi over 6. So really the radians are a lot easier because you don't really have to do much math. You just have to look at the denominator, and that usually tells you what it is. And negative 4 pi over 3, so normal 4 pi over 3 would have been in the third quadrant, so I'm going to go all the way around to here. So my reference angle is this, and once again the denominator is a 3, so I know that this is creating that pi over 3 triangle. Okay, this is helpful because if you're trying to evaluate sine of 4 pi over 3, I kind of showed this at the beginning of class, but we know 4 pi over 3 is down here. And if I know the first quadrant really well, but I don't really know the third quadrant well, if you can just figure out that your reference angle is pi over 3, then you know pi over 3 up here is the value 1/2 root 3 over 2. So then I know that sine has got to be root 3 over 2. And then I just need to think about what's negative in that quadrant. Well, sine is negative there, so it would be a negative value. So that's kind of how I use reference angles when I'm solving. Whew, all right, this is your homework team. I tried to do a whole bunch of optionals, so make sure you pay attention. Like this group is all optional, which is why it has the asterisk. So good luck, and I hope to see you whenever I'm cleared to come back to school.